We are going to conduct our next experiment in Electrical Machines 2 course, and the title of the experiment is load test on three-phase alternator in order to find out its voltage regulation. So let us see the circuit diagram for this. So this is the circuit diagram for conducting the load test on three-phase alternator. So this part is the prime mover, which is our DC shunt motor, right? Then this part is the armature of the three-phase alternator, and this armature winding we are going to connect in star fashion. Since 6 terminals are there, so we will connect this in star fashion. Then the load that we are going to connect across this armature winding is the resistive load, that is three-phase lamp bank we are going to use, which is also star connected. Then about the excitation, this field winding or excitation winding we are going to excite by using this DC supply of 220 volts using this potential divider arrangement. Okay, so in short, this is our circuit diagram to conduct the load test on three-phase alternator in order to find out its voltage regulation. Okay, so now let us see the actual setup and connections. Now this is the setup for the load test on three-phase alternator. Now let us see, this is our three-phase lamp bank which we are connected in star fashion. Okay, so let us, as per the circuit diagram, we can check the connections. Here we have DC1 and DC2, so two DC supplies are there. Out of that, the DC1 supply we are going to use to run the DC shunt motor. Okay, and DC2 supply we are going to use for the excitation purpose. So let us check first the DC shunt motor circuit. So from, as per circuit diagram, from positive it is going to L of the 3-point starter. So this is our 3-point starter. Positive is coming to L of the 3-point starter. Then from A of the starter it is going to A1 or armature terminal of the shunt motor, A1. Then from F it is coming to the field regulator number 1 as per this circuit diagram. From this F it is coming to the field regulator 1, and from field regulator 2 it is going to fixed terminal of 750 ohm rheostat. So from this 2, this going to the field regulator 750 ohm 1.2 ohm rheostat fixed terminal. Then from this variable, you can see this black wire, it is going to F1. Remember here on the table Z2 is nothing but F1, F2. That is the field winding of DC shunt motor. Also this AA, that is nothing but we can treat A1 and A2 terminal of the armature winding of DC shunt motor. Okay, so this from this variable terminal it is coming to F1 or Z. Okay, then A2 F2 or AAZZ terminal we have shorted, and this common is going back to supply. That is black wire, you can see it is going back to supply. So in this way we have first made connections for the DC shunt motor. Now let us see the excitation circuit. So for the excitation circuit, this second 220 volt DC supply is used. Now this rheostat 750 ohm 1.2 ampere, this is we have used as a potential divider. Okay, so accordingly you can see this positive terminal from the supply is coming to the fixed terminal of this potential divider. Then this negative terminal of supply is coming to the second fixed terminal of the rheostat, and from this variable terminal you can see this black terminal where this red wire is connected. This, as per this circuit diagram, this is that wire, red wire, and this is now variable terminal. It is going to ammeter positive DC 0 to 1 ampere range. So now this variable terminal of this potential divider is connected, you can see this wire, it is connected to the positive terminal of DC ammeter 0 to 1 ampere. It is coming here over here as per the circuit diagram. Okay, then from this negative terminal of 1 ampere it is going to field winding. Now see this X, these are nothing but F1, F2 of the alternator field terminals. So from this ammeter 1 ampere it is coming to F1 or X, that is the field winding terminal number 1 for the alternator. Then from F2 or double X that is the second terminal of field winding, that is going back to the supply. So it is going to back to negative. So in this way the excitation circuit is completed. Now we will do the third part. Third part is we want to connect now alternator armature winding across the load. We have to connect across the alternator armature winding. So for that you can see here this alternator has 6 terminals, A1, B1, C1, A2, B2, C2. So we have to connect this alternator now in star fashion. Of course we can connect it in delta also since 6 terminals are available, but now as per the circuit diagram we have to connect it in star fashion. So the second terminal, you can see C2, A2 and B2 are shorted in order to make the star point here for our alternator. So now this alternator is star connected. Now the first terminal A1, as per circuit diagram, it is connected to ammeter of 0 to 5 ampere AC to measure the load current. Okay, so here this A1 has come to ammeter common terminal. Then from ammeter 5 ampere, this red wire is going to the 3-phase lamp bank R1. Okay, now this lamp bank R2, Y2 and B2, these are shorted in order to make the star point. So this lamp bank in this way connected in star fashion. So R phase we have completed. Now about B1, see B1 is the green wire, it is coming to Y1, it is coming to Y1 of the load. And then C1, this is the black wire, third phase of the alternator, it is coming to B1 of the third phase of the lamp bank. So in this way this lamp bank connections are connected, and that is we have connected across the 3-phase star connected alternator. Finally we have to connect one voltmeter of 0 to 300 volt range across A1 and star point of the alternator. So this is the star point. So this wire of voltmeter 300 volt is connected to that common star point, and this A1 one phase we have connected to the common of voltmeter. So this voltmeter is going to measure the phase voltage that is generated by the alternator. This ammeter is going to read the load current. So range is 0 to 5 ampere, and this DC ammeter 0 to 1 ampere capacity, that is basically used to measure the excitation or field current of the alternator. Okay, so that is the entire setup and connections in order to perform this load test on 3-phase alternator using resistive load, that is lamp bank, in order to find out its voltage regulation. Thank you.